If you've ever written even a single line of Java, you have definitely met the static keyword. I mean, it's right there in your very first Hello World program. And, it's one of the most fundamental concepts in the entire language. So in this explainer, we're going to pull back the curtain and really get to the bottom of what static does and why it is so important.
You've probably typed this line hundreds, if not thousands of times. Public, void, main. Okay, those kind of make sense, but what is that static keyword doing there? Why is it so essential for just running your program? Well, to answer that, we first need to understand what static really means at its core.
Okay, so before we can really wrap our heads around what static is, we need to be absolutely crystal clear on what it isn't. And that means we got to start with the default, the normal type of variable you create inside a class, the instance variable.
So here's the most crucial point. An instance variable belongs to an instance or, an object. Think of a class like a blueprint for a house. Every single time you build a new house, that is, create a new object, you install a brand new, completely separate kitchen sink. That sink is your instance variable. So 10 houses means 10 separate sinks.
Let's make this real. Imagine a simple mobile class. It's got 3 instance variables: brand, price, and name. Now, when you create Obj1 for an Apple phone and then Obj2 for a Samsung phone, the Java virtual machine actually sets aside separate little boxes of memory for each one. So Obj1 gets its own space for Apple and its price, and Obj2 gets its own completely separate space for Samsung and its price. They don't mess with each other at all.
Now, this system is absolutely perfect for data like brand and price, right? Because those things need to be unique for each phone. But what happens when some piece of data should be the same? It should be common across all the phones. This is where that instance variable model starts to show some cracks.
Take a close look at the name column here. Let's say we decided to just call all of these devices smartphone. But look what's happening in memory. The value smartphone is stored once for object 1, and then it's stored again, totally separately for object 2. We're duplicating the exact same piece of information. That's just a waste of memory.
Think about how inefficient this is. For just 2 objects, it's a tiny problem, no big deal. But what if your application needs to create a million mobile objects? Are you really going to store the string smartphone 1 million different times? That would waste a huge amount of memory. It's not just inefficient, it's really bad design. There's got to be a better way, right?
And of course there is. This is precisely the problem that the static keyword was born to solve. It gives us a super simple, really elegant way to stop giving data to each individual object and instead give it to the class itself so everyone can share.
And the change in the code? It's incredibly simple. All we have to do is add that one little word, static, right before the variable declaration. That's it. One word literally changes everything about how this variable behaves and where it lives in memory.
This is the core concept right here. A static variable isn't an instance variable anymore. It's a class variable. So instead of making a new copy for every single object, Java creates only one single copy that is then shared across all objects of that class. So what does this sharing thing actually look like inside the computer's memory? Let's take a peek and visualize how our simple one-word change completely transforms the memory layout. Check out this new layout. See, instead of each phone object holding its own copy of the name variable, that variable now lives in one central shared space that belongs to the mobile class itself. So now, Object 1 and Object 2 don't even store the name anymore, they just know where to look to find that single shared value.
And we can actually prove this is true. Let's say we change the name using our first object, obj1.name equals phone. Because obj1 is just pointing to that shared variable, the value in that central class area gets updated to phone. Now here's the key question. What happens when we check the name using obj2? Well, since obj2 points to that very same spot in memory, obj2.name is now also going to return phone. A change made through one object is instantly visible to all the others.
So we've just seen that you can access a static variable through an object reference, like object1.name. But, just because you can do something doesn't always mean you should. There's a much better, much cleaner way to do it. The best practice, the way you'll always see it in professional code, is to access a static variable using the name of the class itself. Just like this, Mobile.name. Why? Well, because this code clearly communicates that name is a property of the mobile class as a whole, not of any one single object. It belongs to the blueprint, not to the individual houses built from it. In fact, your IDE or your compiler will often give you a little warning if you try to access a static variable through an object.
It'll say something just like this, basically reminding you, hey, that's a class-level thing. You really should be accessing it through the class name. It's like a built-in reminder to help you write cleaner, more readable code.
All right, let's pull all of this together into a nice, clear summary. Understanding these differences is absolutely critical for any Java exam or technical interview you might have coming up.
Here it is, side by side. Instance variables belong to the object, static variables belong to the class. You get one copy of an instance variable for every object you make, but you only ever get one copy of a static variable per class, which saves a ton of memory. You access instance variables through an object, but you should always access static variables through the class name. It really all boils down to unique data versus shared data.
So, we've seen that making a variable static ties it directly to the class, not the object. And that's perfect for managing shared data efficiently. This brings us all the way back to our very first question. If a static variable belongs to the class and can exist without any objects, what does that imply when we make a method static? Well, that's the key to understanding public static void main. It's a method that belongs to the class, which means the Java runtime can call it without ever needing to create an object first. And that's how your program gets started.